All right, let's take a look here. The next chapter that we're working on right now is tectonic plate interactions. There's 4 explore pages. We're going to be taking a look at the first one. So make sure you draw your Cornell notes, and I'll go ahead and do the same here. So let's go ahead and draw some lines. And go ahead and put down your date. Right. Today's date is 9/21/23, and our essential question is over here in green on the left-hand side. What are the 3 types of plate boundaries? What are the 3 types of plate boundaries? Yeah, you can come in. And we'll put a question mark there. All right. So Roman numeral 1, and you should already be thinking about this to yourself. What do you know? Hopefully, you should be able to say just off the top of your head what they are. There's divergent, there's convergent, and there's transform. That's always a good habit. That's information you should have learned in middle school. Okay, and the first one that they cover here is convergent. Convergent. Converge means to come together. Convergent boundaries. And if you take a look over here on the left-hand side, the first highlight we have here, it's when 2 plates move together. When 2 plates move together. And that sounds a little ambiguous. It's more like they move towards each other. Towards each other. And we could say we have plate A, and it is moving to the right, and we have plate B. And it's always helpful to try to draw models to help visualize these things, okay? That would be converging. Now, what's interesting here is that this can occur between 2 oceanic plates. It can happen between 2 continental plates, or it can be an oceanic and a continental plate. So maybe that's worth noting. This can occur between any combination of plates, i.e., ocean, ocean, continental to continental, and this is also could be ocean to continental. Okay. All right. Now, one of the things that, as you take a look here, the second paragraph, it says that the features of convergent boundaries are a result of compressional forces. That should make sense. As 2 things collide, they're going to compress with each other. And so features along border. And you might be thinking, what features could those be? Well, think mountain ranges, right? When you have 2 plates that collide, you can form mountains like the Himalayas in India. You can also have subduction if you have an ocean and a continental where the ocean is much denser. So features along the border are due to compressional forces. Okay. There's this idea of subduction, maybe we should, yeah, we'll go ahead and say that, subduction. Okay, and this is where you have heavy, or what we say dense, oceanic plate when it converges or it collides with continental plate, um, sinks when it collides with continental crust, which is less dense. Okay, and you got to know these things. Okay, now why is ocean plate more dense? Well, uh, the type of mineral content that makes up ocean plate and the fact that it's under a lot of water compression are going to account for this. But you can see I've highlighted over here on second paragraph, it's made up of a lot of basaltic rock. Basaltic rock. Whereas continental plates are made up of a different type of rock. If you've been to Yosemite, you've seen granite or felsic rock. Okay, these would be felsic or granite, or you could say granitic rock, right? And as you know from your quizzes and tests, lots of times these things pop up as options. So if you're not really doing the reading and trying to understand this, you're going to miss out on a lot of valuable information. Okay. And so here on the left, you have a nice image showing subduction. On the left-hand side, you can see that the oceanic crust is converging and it dives down below. And in the process, you can see that it's producing um, uh, volcanism along the coastline. You can see that hot chamber of magma, and there's a vent of sorts that's going up, and you can see that it's steaming up on the top there. And you often find that wherever you have subduction going. Okay. Now let's go put down letter B here. When you have convergence of two continental plates, you can see that we've got that highlighted. You have a mountain building event. So let's just write down mountain building events. Due to two continental plates converging. And what happens is, as it's almost like having two pieces of paper on a table, and you just slide them towards each other, and as they hit, they kind of scrunch up, they crumple up on themselves, forming that mountain. Okay, so you could just go ahead and draw down a plate A, and as it converges with plate B, you get something like this. Plate A crumples up, and plate B, let me just change plate B to a different color just so we can appreciate that. Plate B also does that. And we have this crumpling effect. They crumple together, forming mountains. Okay, and one of the products is as you can see here highlighted, metamorphism. You have different types of rock. One of them is metamorphic rock, and this is one way you can produce metamorphic rock in the rock cycle. Can result. Okay, metamorphism. All right. And it's worth noting, you can have earthquakes under these situations. Earthquakes can happen. Okay. And of course, earthquakes especially happen with transform boundaries, which is a different sort of thing altogether. So here in this picture, you can see this continental convergence. And as always, I encourage you to examine these uh, pictures here because they give you some good questions. For example, what events occur as they push together? You may actually want to pause your video right now and reflect on that and answer the question to the right. Okay. Now they do provide you with a case study. The Himalayas. Himalayas are over there by Nepal and China and India. And you can see that you're dealing with two plates here. You've got the, let's go all the way down here, the Indian plate. I don't know if they actually say that here, but that pink plate is called the Indian plate. And then you also have the Eurasian plate, Europe and Asia combined together. And as you take a look at the image, you can see that it has been moving northwards, the Indian plate, and it has been colliding and still is colliding um, into Eurasia. And it is that's what's responsible for currently Earth's tallest mountains, the Himalayas. It's because of this collision between the two plates. And this is an example, which I encourage you to take some time to read. And now let's take a look at the second type of boundary. We're going to talk about divergent boundaries. Okay, so this was Roman numeral 1, converging. Now we're going to take a look at Roman numeral 2. And we're just going to continue our Cornell note line down here. Take that all the way down. Roman numeral 2, divergent boundary. And we can take the highlighted definition. There forms when two oceanic plates or two continental plates move apart. Okay, notice in pink here, divergence does not occur between ocean to continental plates. Okay, so let's write down a definition. Forms between two oceanic plates. It forms between two continental plates. But it does not form between oceanic and continental. Okay, so not between ocean and continental. And I could see your one of your quiz questions possibly being something along that nature. Now, as far as features are concerned here, this is important here. If you take a look at the third paragraph down, a triple junction in the shape of a Y marks divergence of three continental plates. Okay, so you can have a peculiar sort of situation where we'll call them uh, triple junctions. Let's just call it that way, okay? Triple junctions, where three plates are diverging. form Y type borders. All right, so let's go ahead and take a look here. So first, I'm going to come up to the right here, and we're going to say that in a typical divergence, you might have plate A, and plate A is moving that way, and you have plate B, and it's moving something like this. And there's going to be a lot of force, what we call tensile or tension forces, extension forces are going to be at work here as these pull apart. And you should certainly be thinking about seafloor spreading. I.e. sea floor spreading, because that would be an example of divergence between two ocean plates. Okay. Now, if we come down here to our triple junction, and they give an example here on the left, they start talking about the Gulf of Aden and the Red Sea over between Africa and Arabia. And they also talk about the African Rift Valley. And in both cases, if we take a look at a picture here, I'll go ahead and open up a picture. You can see here that the dotted line here represents a large chunk of Africa that is a rift valley. And it's actually, there's the right-hand side, the African plate is the Somalian, I guess, plate is pulling away from the left plate, the African plate, the Nubian plate. And both of those are pulling apart from the top here, the Arabian plate. And hence, that's where you get your Y shape. So let's go ahead and do that here. We have perhaps, we'll take some black here, and you might have a plate A, and maybe it's pulling in one direction. You might have plate B pulling in another direction, and you might have plate C pulling in its direction. And this is kind of forming that Y shape. All right, this is the Y shape. All right, we could go ahead and say, see, this is that kind of like a letter Y. And this would also form rift valleys. Are often associated. Okay. And let's just go back to our text there, make sure we're getting everything. And then they also have a, get up here. And here they have a case study for you, the Mid-Atlantic Ridge, which we've already talked about a little bit in the last chapter, okay? But for refreshers, when you take a look at this picture here, you can see the North American continent, the South American continent, you can see the African continent, and going down the middle is this kind of interesting zigzag-ish kind of line called the Mid-Atlantic Ridge. It's actually a series of sections of divergence that's going on, and it's kind of forcing the Atlantic Ocean to spread apart about 10 centimeters per year. So the continents are drifting apart. And that, again, helps explain continental drift, you know, the whole tectonic plate theory. Okay. And then the last type of boundary then is, let's go ahead and write this down here, Roman numeral 3. This is going to be your transform boundary. And if you take a look, we have highlighted there, it forms when two plates slide past one another in a parallel fashion. Okay, so we'll first write that out. When two plates slide past each other, parallel. Okay. And it says there, sentence number 2, transform boundaries can occur under the ocean or land. And that third sentence, crust is neither made nor destroyed. Okay. What does happen, though, is as they slide along each other, as they rub along each other, they develop a lot of friction. And eventually, once the friction is overcome, you get a very large shaking. That's what we consider to be those big earthquakes. All right. So let's go ahead and write that down here. We're going to draw a picture. We've got plate A. We'll put that in a box. And you can see here that plate A is sliding that direction, and plate B is sliding this way. And what's happening is the friction, the rubbing, is happening between there. Okay, the friction. And this can lead to large earthquakes. This is an example, can be seen here with the San Andreas Fault. Okay. I'm going to hit pause here for just a second. Hopefully this is not too much of an interruption. All right, and as we continue, let's see, is there anything else that we missed here? They give you a case study, the San Andreas Fault, which I strongly encourage that you take a look at. And then you have some homework questions related to that. And that is it. Okay, so as we go back up here, is there anything else we want to add to those notes? When two plates slide past each other, parallel, let's just put down lots of pressure develops and suddenly releases, and boom, you have your large earthquake event. All right, that's it. If you have any questions, don't ask me, ask somebody else. No, just kidding. You can send me off a chat. Good luck on that, and we'll talk to you soon.